Okay, we have jumped into the exciting fourth part of the introductory organic class, and the topic now is addition reactions of alkenes. And this is a really powerful general reaction because if you have an alkene, you've got a double bond, and the double bond is quite a bit more reactive than the single bond. So oftentimes you can get reactivity at the double bond, and depending on what reagent you're using, you can get all kinds of different types of products. So in terms of functional groups, you can have a double bond, and the addition reaction is when you add a molecule that's going to react with this. And what will normally happen is rather than having the double bond with pi bond, that's going to be replaced because the two parts of the incoming molecule are going to attach to the two different carbons in the double bond. So switch it up to more of a Lewis structure here. So you have ethylene plus an incoming molecule, and it does an addition to add the one half to one carbon, the other half to the other carbon. And depending on what the identity of this molecule is, you get all kinds of different products. So let's go in a general overview of the types of things we're going to see. If we have ethylene and we add hydrohalic acid, so something like hydrogen bromide or hydrogen chloride or hydrogen iodide, the strong acid will react and you'll end up with the hydrogen on one carbon and the halogen on the other carbon. This reaction is called hydrohalogenation because you're adding a hydrogen to one carbon and a halogen to the other, and that's going to require one of the strong acids. You can use HCl, HBr, or HI and get either a chloride, a bromide, or an iodide. So in this case, more of a skeletal representation. If you add HBr to a double bond, you get a bromide. Another one you can do is called the hydration, and if you're well hydrated, you've been drinking plenty of water. So if you have a hydration reaction, it adds water. And in this case, it'll add a hydrogen to one of the carbons and an OH to the other carbon, and then you get an alcohol. So we talked about the different types of functional groups. If you wanted to make an alcohol, you could do a hydration reaction of an alkene and you'd get an alcohol. Now the water isn't powerful enough to react with the alkene on its own, so you generally need a catalyst. In this case, sulfuric acid would work well. The strong acid would kick the reaction off, and we'll go over the mechanism because we're right now just looking at an overview of what happens, what the starting materials are, what the products are, but we're not describing at all how it happens. When we look in detail in the mechanism, that's going to be much more powerful because then we can see how it happens and the details of what we'll get by working through each step of the mechanism. So that's where the real understanding and power of organic chemistry is you understand how things happen. That'll really help you to figure out what can happen and what you will get if it does happen. The last type that we're going to look at in terms of addition reactions, we're not going to look at the mechanism too deeply here, but if you do hydrogenation, that's when you add hydrogen. And if you're into nutrition, they have partially hydrogenated fats and such things like that. If you add hydrogen to something, hydrogen to an alkene, and there's plenty of double bonds in most fatty acids. So you add hydrogen, now you're going to add a hydrogen to each side, and in a skeletal sense, like I've been representing that a hydrogen has been attaching just to emphasize what's new. In a skeletal drawing, you don't have to put the hydrogens on because they're assumed. But again, just to show there are new hydrogens on this one, I will put them in there to say the double bond is replaced by the two connections to new parts of the molecule. So in a hydrogenation, you add hydrogen and you turn an alkene into an alkane. So this is the overview of different reactions we'll see. And we'll get into the details as we look at the individual mechanisms.